Hello and welcome to Keysight Network and Data Center. I'm Michael Koenigsman, expert in photonic application. Today I'd like to give you an overview about IQ offset error and its root cause. IQ offset indicates the magnitude of the carrier feed-through signal, or in other words, it is a measure for the amount of unmodulated light passing through the modulator. IQ offset errors could stem from the unfavorable bias voltage settings for the I and Q modulators of a nested Mach-Zehnder modulator. The constellation diagram on the right shows the center of the measured constellation shifted with respect to the referenced constellation shown in red. The IQ offset is basically calculated from the ratio of the modulated amplitude, represented by the red arrow from the center of the reference constellation to the outermost constellation points, to the length of the shift of the constellation center, represented by the light blue arrow, expressed in dB. A larger IQ offset value indicates more unmodulated light. A smaller value is indicated a smaller amount of unmodulated light. In practice, an IQ offset in the order of less than -25 dB is desirable for most of the commonly used modulation formats. The OMA software can measure the IQ offset error and display its value in the optical properties window. Here, a value of -6.5 dB is determined for the IQ offset by the OMA software. An IQ offset can be caused by unfavorable bias settings for the two I and Q modulators childs of a Mach-Zehnder modulator. Over long periods of time, the bias voltage shifts can occur as a result of temperature changes in the environment of the modulator. Ideally, the bias voltages are set to the minimum power transmission point in the middle of the linear range of the field transfer curve, called the field quadrature point red circle, or at minimum power on the blue curve. At this operating point, most of the light is modulated by the RF signal applied to the I and Q modulator childs. The amount of modulated light is at a minimum. A change in the bias voltage moves this operating point along the red field transfer curve, which result in an increase of the optical power level at the output, which is dominated by unmodulated light. See the mathematical relationship between field and power transfer curve in the lower right box. This in turn moves the measured constellation out of the center. The block diagram of a Mach-Zehnder modulator illustrates this. For troubleshooting purposes, it should be considered that a combination of both bias voltages can be responsible for the IQ offset. The effects of an IQ offset error are best viewed in the spectrum of the signal of interest. The upper right-hand side window shows the overlaid spectra from the dual polarization signal. On the left, you can see the constellation diagrams from the two signals in the polarizations. Below the constellation diagrams, two windows are displaying the optic properties of the dual polarization signal. They will be used to compare the IQ offsets and EVM readings later on. It can be observed that the constellation on the left moves out of the center of the measurement window, while the one on the right remains in the middle. Please note that depending on the demodulator settings, the effects of an IQ offset error may appear less dominant in the constellation diagrams. At the same time, it can be observed that with increasing IQ offset, a peak stands out in the middle of the green spectrum. This peak is caused by the amount of unmodulated light and is typical for the IQ offset error. A marker is placed at the position of the peak on the spectrums belonging to the distorted constellation diagram on the left. The lower left-hand side window shows the IQ offset error reading reaching up to -6 dB. Also, you can see that the EVM readings on the left are getting worse with the increase of the IQ offset, while the EVM readings on the right remain stable. Typically, the IQ offset is a static impairment. For this illustration, the IQ offset was varied dynamically over time. The lower right-hand side window shows the IQ offset readings over time. In practice, attempts are made to achieve IQ offset values in the order of less than -25 dB, whereby more complex formats tend to be more susceptible to IQ offsets. In case of higher modulation formats, it may be beneficial to aim for values even lower than -25 dB. If you find this video helpful, follow the link below for more OMA software content. Don't hesitate to contact us for any inquiries. This is Michael from Keysight Technologies. Thank you for your attention.